And then, talking about inspiration, we would like to welcome the next speaker. The next speaker is Lars Hesselgren. And his name is in Swedish, and I know you speak some Swedish, but you're also invited here to come from abroad as a special guest for this keynote, as a keynote speaker to give us inspiration. So give us inspiration on the future of transportation, and you are Director of Research on the PLP architecture. And
Correct.
Thank you very much for coming.
Thank you, not at all. I have a dream, and last week I was in Paris and presented the dream, and for them it was a nightmare. So I think we should be careful with our choices of words sometimes when we just think of these things. But clearly one of the things that's going to happen is autonomous cars are coming. So what's going to happen to cities when we do that? Well, can cars morph into virtual trains, is my question. And that one is going backwards, so the forwards one is going to be that one. That's why I was painting backwards, okay? So, sorry, yes. Video, but necessary 2 minutes.
Paris, London. It's horrible. But look, a park. It's beautiful. And it's much better than streets. So, how could we actually do this? If we look at the new park we've just created, what made it possible? If we look underneath ground, we see that we have put the cars into tunnels. Here's a simulation of how such a system would work.
Approaching London, there is a usual traffic jam on the M4. This driver, who has a meeting in the city, is very happy to have booked a car tube slot.
There's no stations.
Getting close to the M4 car tube entrance, the car prepares to join the platoon and the driverless mode is engaged. This means that the driver can take his hands off the steering wheel. The car tube system is now driving the car. Journeys with car tube are astonishingly fast. As the car enters the tunnel, the system offers choices of entertainment. The driver might want to watch a film or do some emails. Instead of the noisy fracas of stop and start motorway journeys, the car tube is quiet and smooth, flowing at a constant speed of 50 miles per hour. The car becomes a cocoon of privacy.
And here we are approaching a station where we are going to get out, and the car will either go and park itself, or it will go off and pick up some other passengers. But in principle, we don't have to worry about it.
The car will be in constant communication with the driver's mobile, conveying useful information instantly, such as whether the other attendees in the driver's meeting will be arriving on time.
And here is an example of how we can actually make all this system work. If you compare it with an ordinary road system and train system, you don't have to park your car and get onto the train. The car will take you directly to your destination, so you don't have to get out of the station and go up the escalator and change to another underground railway or anything else. You simply stay in your vehicle. Whether it's owned or shared is irrelevant. It's basically an automated transportation system. But it happens to be a modern autonomous car. And then when you arrive at your destination, you can go directly to where you want to be, and your vehicle will be driven off automatically to somewhere else. This is simulation of such a system in London, and this data is taken from the underground system. Of course, every car is individually identified, and we track exactly where they are and how they're going through the system, but it ensures that there will never be any traffic jams because it is entirely centrally controlled.
Right, so I'm going to give you a short lesson in topology. This is how a lift system works. It's a completely stupid system because it's a single track with a single vehicle in the track. And nobody is doing any traffic system based on this idea except the lift manufacturers. Which is why we designed a lift system that is actually a system that loops around and has got multiple vehicles in the system, like this. This is something that we're continuing research on this, and I've just got contact with my advisors on linear motors. They designed 6-kilometer lifts with linear motors. We're looking at a couple of kilometers. Now, when you look at conventional metros and conventional underground lines, this is usually the way people think of it and how it's laid up. And the problem is that every time you change line, your change is on foot, which is kind of like slows everything down. And it's a silly system. So why are we always thinking that those lines going left and right should be grouped together? Why don't we split them apart and have a grid layout, which is like, say, Manhattan? But think of the internet. The internet is modeled on this kind of idea. And then you put in your switches, and these switches ensure that you can travel in around in the system. So it's now a switched network. And this switch network, what you do is you make sure that the switch network always runs at full speed, because wherever you get off the network, you have a stop that is off the network. So the network never stops. It's like a motorway. Now, the one thing that people keep on forgetting about transportation is that the capacity of a system is a function of the spacing between the vehicles in the system. Applies to any system whatsoever. Now, the point about this is that we as drivers are incredibly bad. So we're keeping 60 meters apart when we're driving on the motorway because our reaction time is very slow. When we hand over to an autonomous car, we can put it down to 0.1 second reaction time instead, and suddenly we've got 6 times the capacity on our roads. This is the big calculation. This is the only calculation that matters when you do any transportation system. The passenger density, that is the person per meter of the linear meter, times the speed gives you the capacity of the system. It is very simple. So you look at cars, and cars are actually pretty, they're spread out. But once you compact them together, they're quite good. Trains are even better. And they are very compact, and they are very inconvenient because you have to stand in the rush hour. It's horrible. But their average capacity is not particularly high because you've got spaces between the trains. You've got the sausage coming along, packed with people, and then there's nothing, 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 and then comes the next one. Whereas you want to have a system which is continuous. So what sort of vehicle? Well, there are all sorts of vehicles that can fit into tunnel systems or into any segregated train system. Does it matter what they look like? No, it does not matter what they look like. It really doesn't. What we do have is we have the technology to actually control the system, and the system controls that matter, not the shape of the vehicle or how it's propelled. Although, if you want to propel it efficiently, of course, you should have electric propulsion. So whenever I describe the system, people, as long as I describe a transport pod system, everybody says, that's absolutely wonderful. We love transport pods. When I then say we have got transport pods, they're called cars, everybody freaks. Okay, so the car industry, of course, is now switching to electric vehicles, which is very sensible and a good thing too. So I'm very happy that they're doing that, and I think that is going to take off. I mean, Volvo here certainly announced that they're going to do hybrid cars. So this is the capacity calculation, really. So if you look at Crossrail, and if it's packed full, that is absolutely to the gills, it's got 1,500 people, and they're looking at every 5 minutes, they can probably double that to every 2.5 minutes. So instead of 18,000, they can probably get 36,000 passengers an hour. However, if you put 4 cars and you run it at a modest 80 kilometer, but you don't stop, then you get about 40,000. So, you know, a Crossrail system, any kind of metro underground system, and a car system which is packed tight and continuously running have similar capacities. So it's not to do with what you do it's to do with what technology you put into the tunnel. Now, the segregated track is really important because if you have to have a capacity, a system with decent capacity, you need to have speed. And you can only get that on segregated track. It's because if you have run autonomous cars on ordinary roads, you've got kids running in front of it and it stops it. And so the mixed traffic inevitably slows down your speed. So therefore it drops your capacity. So if you want a high capacity system, you do need to have a segregated track. But this is where trains have come and shown this. All trains are segregated track train systems. So if we have a look at this, we think, okay, well, here's a train. Well, wouldn't it be useful if each of those cars, cars, actually traveled to a different destination? And if they did, we could segregate them and separate them. And if we made them run continuously, we could actually have a lot more of them. And if we have a lot more of them, we then say to ourselves, well, what is the shape of those particular individual vehicles? Well, it could well be a car. Why not? What's different? So this is how we were thinking about a network. So clearly what you need is a primary network. And you need a secondary network to drop passengers on and off and pick passengers up and down. And the key thing, of course, is the simplest junction. So this is your internet analogy. So can you make this intersection work at speed at all times? And of course, you quickly realize that it is absolutely essential that you know which vehicle is going to get down in which direction, in which lane. So you need to be able to have a predictive system where you can actually know in advance what traffic is coming down the pipe and where it's likely to go. So when you look at the grid layout, as opposed to a single line system, the big advantage with the grid is that you can travel in the grid in a different way, depending on the loading on the system. And if you think and look at this, you'd realize that the inputs mean that the grid itself can always cope with the capacity of the inputs. The only thing that needs to change is the way you travel around in it. But what is problematic with it is the arrival point. If the arrival point gets congested, you're stuck. The whole system stops. So you need to have predictions to do it. Now, when you look at autonomous car and you overlay this on a sort of standard motorway intersection, you realize that these wide lines can replace all of the junk in the middle. That's the difference between having a controlled vehicle and having a non-controlled vehicle. We are running around in non-controlled vehicles. It is a bad idea. So this is another simulation and showing how we are tracking the different vehicles within the system. And of course, you can see that the drop-off points are off the main grid. This is similar to what I showed you before. So what is the station look like? Well, in congested cities like in London, you might need to put them underground, and we'll be looking at different configurations. So that configuration on the left is equivalent to London Underground station in terms of capacity. But of course, in many cities, the ideal station is the street. And there you are, Manhattan, there's the street, there's the station. Why do you need to design a station? You don't need stations. So there are situations, of course, when you're getting stuff up onto the surface is tricky. So we've been looking at different lift systems to getting them up onto the surface. But this is the key, is the booking system. You need to be able to book ahead for a slot in your system. And it could either be a private car or it could be a shared car. A private car happens to be available when you want it. We clearly need to have traffic systems which are sustainable and therefore electrical. But also one of the big things is we need to cut down noise. And cutting down noise, the one middle picture, is people die when they live around the motorway and it's very noisy. These are the old ideas that we need to throw away entirely. The idea that you drive your car to a station and then you leave your car for 8 hours doing nothing is completely crazy. Traffic timetables are insane. The way we're laying out our metro systems is not very clever. So this is our proposal for London. So this is sticking tunnels that are the size of the tube tunnels. Ordinary cars, white vans and the like can go in it. You connect it up to the existing motorway network. Your station is your motorway. It is a moving station. There is no need for any additional station at all. So this is what the system might bring you to New York, to Shanghai, to all these other sort of places. And this is, of course, where you begin to think, aha, how do you integrate it with existing systems? Well, what you do is you set a lane aside for autonomous vehicles, which are running in platoon fashion and which are automated. And there are already several suggestions along those roads. So people have been talking about Seattle, Vancouver. Lots of studies have been doing in the same area. The point about it is it can seamlessly be connected to an underground system or even an overground system, which will take you to where you want to go. The main thing is that what you need is a control system so that you can keep the system running. You cannot have a system that stops. If it stops, your capacity drops to zero. Therefore, you need to control how it goes in. So this is a policy. It's a digital policy. You control how you get into the car. So you might have only shared multi-occupancy in the morning and after the run, and free running in the day. This is what I call the Trump policy. This is when, if you have money, you get into the system. And this is the socialist policy, which says, no, that's a complete rubbish. That's a stupid idea. You should only use municipal minibuses where you shared vehicles and you share destinations and the like. The point about both of these things is this is a digital policy. It can be changed at the flick of a button. It is not built into the infrastructure. And this really matters. Why do we build our assumptions into the way we build infrastructure? And I say we should stop building assumptions into infrastructure and move the assumptions into the digital world where it should live and where we can decide and control it in all sorts of clever different ways. So we've been talking a lot about tunneling, and of course tunneling has now come to the fore, and Elon Musk is pioneering tunneling. I think his tunneling ideas are great. I think his transportation system, top right, is completely potty, because why would you want to put it on a specialist vehicle, your car? Why don't you just let the car do the job? It's completely crazy. So one of the things that I think we know from experience is that, how are we doing for time? I have no idea. Cars and roads are more flexible. We saw it on the slides between how the roads were changed. We have voted for the road. We, as a public, have voted for the road. And why have we voted for the road? Because it is a flexible system. Flexible systems is what we all want. And flexible systems is what we need to work towards, I believe. So this is just having a quick look at how could you implement such a system in a local situation. I happen to know, if you know London coming in from the M4, it's a nightmare. They were proposing a 3-lane motorway both ways, cost about 3 billion, not going to happen. For something of a fraction of the cost, something like a quarter of the cost, we could begin, if you have controlled vehicles, to build tunnels in that situation, and then we could augment them and get additional help on various points in the system and replace the existing system gradually over time. And this is the last slide, I think. This is the last slide of the sharing thing. Of course, this won't happen overnight. So one of the things we have are bus lanes. So bus lanes can be sold off to transportation technologies with autonomous cars, where the autonomous cars use the same system as the buses. Of course, eventually the buses will die and will be replaced by these autonomous cars. But we can begin to implement this by looking sensibly at our policies about who gets access to which part of the road. So this is what Corbusier promised us from the 1930s. And this is actually what we got. And this is what we built. And I defy you all to think this was a good idea. This is not a good idea. This is a horrible place to live in. This is a nasty place. It destroys our environment. It does every single thing. That is why you don't want to have cars. But if you look at an ordinary street and you say, no, the cars don't belong in the street. The cars belong below the street, because the street belongs to people. And people is what matters. We need to live together. We don't need to be segregated. If you want to be transported, by all means, be transported down underground. That is absolutely fine. But the streets are for people. We know that we've destroyed our cities entirely by building motorways straight through our big cities and destroying them utterly. This is what we should be doing, not that. End of my talk. Thank you.